Hey everyone, this is Ridip here, and today we'll be talking about WASM. So let's start with what is WASM. Before we move ahead, I request you to please like, share and subscribe my channel so that I can bring new videos for you. WebAssembly is intended for a modern web browsers. However, it is a low-level assembly-like language which will run with a native performance, near native performance I mean. Let's try to understand the WASM in simple terms. Now, where do we execute our web files? In browser, right? So we have a browser. So each browser has a JavaScript engine. That means we can execute our JavaScript file inside a browser using the JavaScript engine. Currently, browser understand three files, which are HTML and CSS, and third file is our JS file, which is intended for our logic part, right? So this JS file executes at the runtime and then our content is been served, right? It also make our content a dynamic content, right? So our browser currently is handling HTML, CSS and JS. However, JS needs to be parsed, then compiled, then optimized, and then it's converted into a executable file, right? So it does take some time. And if we are having some applications like our native application for video gaming or editors, video editors, music productions, they require a lot of power for computing, which JavaScript right now doesn't do, and it does require the power which is not available in JavaScript, I can say right now. So WASM was started. Now what we can do is we have our source code file which is written in some high level language and then compile it into WASM. Now this WASM will be a compiled file which will be running at a native speed, or we can say which will be running at a 20% lesser speed of native code. However, it's much more faster than JS in some scenarios, right? I will explain you why I said in some scenarios. So we'll be compiling our source code into WASM, and then this WASM file will be given to our browsers. Now these WASM files can be executed inside a browser. Yeah, it does has a support now inside browser where we can run the WASM files. Most of the browsers, Chrome, Firefox, Edge, are supporting WASMs, which are then used inside JS. So if we have any function written like counter function we have, which we were writing inside our JS file, we are now going to write inside WASM file, and this WASM file will be taken inside JS. So the function will be called through JS. However, it will be written inside these WASM files. So it's simple that we will be writing our code into some high level languages from which it will be compiled and then created a WASM file, and this WASM file can be executed in the browser. So is it simple? Now let's talk about source code. Now source code is written in high level language. High level language means in C, C++ or Rust. So currently C, C++, Rust can be compiled into WASM. Also there is an assembly script which is like a subset of TypeScript, so which is also can be compiled into WASM using binaries of C. So that is something new that I'm been exploring, and I will be talking if possible in the next video. But for now, C, C++ and Rust can be converted can be compiled into a binary file. So we'll be having something like this. This is a binary file which is of WASM, which can be a readable format. .wat file is been provided, so it's a readable format. However, WASM is the file which is actually a executable file inside a browser. So you can see this is a binary file. Now inside JS we do fetch these WASM files, and then the functions which are written inside C or C++ or Rust can be accessed through JS, right? And vice versa is also possible. However, WASM cannot directly access the web APIs or DOM, so JS is required. JS is the layer between WASM and HTML, which will be taking the code like functionalities or anything which is required to the HTML. So we can't say that WASM is going to replace a JS, and surely WASM can run with JS as well as JS runs with the WASM in, I can say, right? So WASM is just a binary file which is executable and then fetched through JS and accessed like DOM APIs or anything can be accessing WASM through JS. So we have a source code which is written in C, C++ and Rust, which is then compiled into WASM and then used inside a browser. Now the question comes into my mind that why we are doing such things. What is the need for doing this? The first thing that comes to my mind is the speed. Now, as I said, JavaScript requires some time for parsing, compiling and then optimizing everything, right? It's going to take some time, whereas WASM is a binary file which can be executed directly. So the time required for JS as compared to WASM will be less. However, in some scenarios JS do perform well. So when you are deciding between WASM and JS, make sure you are doing something which is more computational or require high computing power, like video graphics or video editing, music or anything like that, which JS takes time. Then take WASM, otherwise your JS can be executed very well. So as I said, WASM is not going to replace JS, but where we required for more computing, we are going to use WASM. Second thing is flexibility. Right now if you have to do anything, we do depend on JS to be running. So anything we are doing for browser is written in JS, right? However, now you give an option to the developers like C, C++ or Rust to write the function which can be used within your browsers. That's a flexibility. And third, we can say is a portability, where the WASM is not just for any specific machine. WASM can be executed inside browser. That means the machine may be Windows, Linux or other machines. So it is not dependent on the machines or OSs. It can be executed within a browser. So we can say speed, flexibility and portability can be given by a WASM, and that's the reason why we should use WASM wherever required. That's it for today, and in next video we'll see a hands-on coding on WASM. If you like it, please don't forget to like, share and subscribe, and also comment whatever your thoughts are there on the WASM in below comments. Thank you. Have a nice day. See ya.